Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at, of course, the concept of the intermediate value theorem, and we're going to look and examine the close relationship between this specific type of a theorem with the mean value theorem and the Rolle's theorem. Now, from our previous discussion, we have extensively done our discussion on the two other theorems which I've mentioned for the mean value theorem, and our special case is the Rolle's theorem, and try to show a various range of what we refer to as critical points and how we can describe them in terms of course, the points of C and the points of inflection. Now, in this particular discussion, we're going to look at the concept of the intermediate value theorem, which is going to be basically a elimination of the two previous theorem which we have said. Now, we shall consider this specific curve for A which I have given. And in a sense, we're going to see that the intermediate value theorem is going to create a criterion for us isolating the real solutions of equations of this specific form, whereby we're going to have f of x equivalent to 0. Now, in a sense, this specific theorem is going to be assisting us trying to create solutions for such a kind of course, functions. And the lower part of the board, I've given one evaluation example that is going to be assisting us trying to, of course, confirm that that is true for such a kind of course, equations. Now, we're going to consider this specific theorem. And the theorem states that for a function that is continuous on a closed interval, which we can give in terms of f, so we are going to have it as a statement form. So if f is a function that is continuous on closed intervals over a and b, and n which is going to be given a number, n is n number between fa and fb, then we're going to have at least one number, then there is at least one number c between a and b, where f of c is equivalent to n given as such. So in a statement form, this is going to be forming a summary of this specific intermediate value theorem, whereby we have said that this can be given in a statement form, whereby we are going to have a function that is given in terms of f, which we can describe as such. So it's going to be a function of f given as such, which can be given in terms of f of x. So this is going to be given as a function that is continuous on closed intervals over a and b, and there is n, and n is n number between the f of a and f of b, which are going to be corresponding values on the y-axis of these two specific intervals. So we're going to have that if a function f is continuous on a and b, and n is n number between fa and fb given as such, then there's at least one number c between a and b, which is going to be given as such, and the f of c, which is going to be a function, of course, on the y-axis, given in terms of this specific value of n. And as I've said, this specific kind of a theorem is going to be assisting us for creating a basis for us in isolating the real solutions of an equation of such a kind of a form, whereby we're going to have basically f of x is equivalent to 0. Now, in our particular case, we're going to see that we're going to have some of the conditions established between these two specific intervals, whereby we had said that if a and b are going to be forming a set of real numbers, then we can consider this specific case for a positive increase in x and y direction given as such, and try to give some of the conditions. Now, in a sense, we're going to see that the first derivative of course, this specific function f of x is going to be given in terms of f prime over x given as such, and this is going to be, of course, a continuous on these particular closed intervals of the value of a and b given as such. And as we have said from this specific statement, then that's going to be true. Now, the values of fa and fb in this specific graph are going to be having a positive value. So we're going to have fa and FB being positive values. And in a sense, we're going to see also that the f prime over x, which is going to be, of course, obtained from this range of values between a and b, is going to be a positive value. And therefore, we are going to have this one given in terms of, perhaps I can do away with this specific statement. Hope that we have understood in this specific case. So if we consider this specific kind of a graph, we're going to see that the f prime over x is going to be defined between a and b given as such. And it's going to be, of course, going to be the first derivative given in terms of f prime over x. Now we're going to have these specific values for this fa and fb being positive, and therefore that implies basically that we're going to have that specific point over n being positive as well. Now the first derivative with respect to this specific function, which is going to be, of course, given in terms of f prime over x as well, is going to be given as a positive value. So therefore it's going to be different from other critical points which you have been establishing for the Rolle's theorem and of course the mean value theorem from our previous discussion. So this is going to be a condition for this particular type of a curve. Then therefore we can consider the case of this specific value, whereby we're going to see that there's only one and one solution of the equation that's going to be giving us the value of x is equivalent to 0 between these specific intervals of a and b. And therefore we can consider the case of a lower section, whereby we're going to equate this specific function which we have been given in terms of course, x, or the function given in terms of 0. The result of a function is going to be given in terms of 0 according to these statements, and then therefore we're going to see how we can, of course, show that we are going to have exactly one root between the two intervals. Now, in a sense, we're going to do an evaluation of this specific equation, whereby we're going to have x to power 3 plus 3x plus 1 is equivalent to 0. So we're going to show that this specific function is equivalent to 0 has exactly one root. So we're going to create, of course, what we call an evaluation for this kind of an equation, whereby we're going to have it given in terms of this specific, of course, equation that we're going to have a derivative. So we are going to have this given in terms of f prime over x is equivalent to 3x to power 2 plus 3, which is going to be given as such. So from our previous statement, we're going to see that by the intermediate value theorem, we're going to have a c between these specific intervals. So this implies that basically the range between these specific values of a and b, the value for f prime is basically going to be a positive value, and therefore we are going to see that we are not going to be having this such a kind of a scenario whereby we're going to have this particular function of f prime equivalent to 0, since we're going to see that these specific values are going to be holding for a positive value between a and b. So if we consider that specific condition, then we can have this specific function given in terms of this representation, whereby the value of x at this specific point is given in terms of course, c to power 3, 3 to power 3 to c plus 1 given as such, which is going to be equivalent to 0, and the value of c is going to be a positive value at this specific point. So in a sense, we're going to see that this is going to be having a specific root which is going to be established by this particular, of course, number of c. And as we go ahead, we're going to have different evaluations for this specific aspect of the intermediate value theorem together with the Rolle's theorem and the mean value theorem, and try to see the difference between the two. So kindly check our description boxes for various links of other videos. Engage us in the comment section, and also ring that notification bell for an update on different discussion we're going to do in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.